Thank you, Lenore. Hello, everyone. I see that there are a lot of issues related to my name, so I'm going to add one story about my name as well. For years, they have been calling me Thanos. And recently, I found out that Marvel's superhero who destroys planets is called also Thanos. So that's an addition. But you are safe today, at least today. I would suggest that you use your textbooks wisely, though. OK, I'm very excited to present to you Anactisis. Anactisis comes from the Greek word for recovery and reclaim. And it makes a lot of sense because the mission of the company is to extract and recover selectively critical materials from large volume industrial wastes, critical materials like rare earth elements, scandium, primarily scandium, because it's one of these excellent elements that you can dope and inject in different materials like alloys, aluminum alloys, and increase their chemical and physical performance immensely. So scandium these days has been used for bike frames and luxury sporting goods. But there are numerous applications that are hungry to use a little bit of this material, especially in the aviation and aerospace, where you can get the scandium aluminum alloys, where the weight of this alloy comes reduced significantly and can be also used in the space flights. And we know that the space industry is hungry for weight reduction. They are willing to pay $10,000 for each kilogram reduced. And there are other applications, like in the automotive industry, where scandium can be used in the heat exchangers, defense systems, for armor, additive manufacturing in the future, where they are looking on doping and injecting scandium powders in their metallics, and so forth. If we sum up the amount of scandium that we would need for all those applications, we would come up with a number of 2,800 tons. But the problem is that we only get 25 tons per year. The global supply of scandium, it's only 25 tons. But there are enormous opportunities in aerospace alloys, particularly $35 billion in lifetime fuel savings from scandium aluminum alloys, substitution for ordered B737 MAX, or $1 billion increase in annual profitability of OEMs. Then the question becomes, is there a solution to increase the global supply of scandium? And I think there is. Large volume industrial waste like fly ash, bauxite residues, titanium oxide tailings, phosphotailings, mining tailings, and an array of other waste that can be used. The great thing about these wastes is that the amount of scandium that they contain is comparable to mining operations. 12,000 tons market opportunity for scandium oxide from US fly ash and global red mud. As I said earlier, 2,800 tons latent scandium oxide demand in mature and emerging markets, and I'm excluding the automotive industry because it's a future market. So you could expect that this demand would go up. 1,000 tons recoverable scandium from Appalachian fly ash. We are very lucky to be in this region of US where there is a lot of scandium in the fly ash. Definitely, there is no shortage of fly ash produced in the United States. In this map, whatever you see in the orange dots is a coal-fired power plant. Totally 70 million tons of fly ash is being produced per year. 60% of that is being repurposed and reused primarily in the cement industry. 40%, the remaining 40% can be can sustain a steady supply of scandium in the United States. About 70 power plants in the East Coast could produce about 500 tons per day fly ash, which is a nice number for a viable and profitable project. And we can do that with a very simple technology. We take the abandoned waste, we apply conventional engineering, no need for innovation there, and then we innovate the separations technology. We innovate the chemistry. So we produce selective adsorbents, and we have successfully developed our first generation adsorbents where we can extract scandium oxides and a basket of rare earth elements, and we are moving towards developing the second generation of our adsorbents where we will be separating the rare earth elements among themselves. And for the future, we are envisioning a tailored adsorbent where we can extract more valuable minerals from those wastes. In a nutshell, the technology that we are developing takes the fly ash and mix it with some acids, then without any neutralization, contrary to what other technologies try to do, we pass it through our first adsorbent. The first adsorbent, what it does, it pulls out the scandium and the rare earth elements and leaves everything else behind. Then we elute that from that sophisticated Brita filter, and it goes to the second adsorbent where we can then separate the scandium from the rare earth elements and have two sellable products. Our current business model, we have the coal-fired utility dying to get rid of the waste. So some fee can be applied to that. We take that waste fly ash, we process it, we produce the scandium oxide, which is being injected to the metals value chain, and this is where we get most of the revenue back. But the great thing about this treatment technology is that we take waste in, but we produce a secondary product, which is a fly ash, which is now on spec that we can then sell to the fly ash marketer, and creating a new revenue stream that fits back to the coal-fired utility, a fraction of it at least. Competitive advantage. As I said earlier, direct use of acidic feedstocks, no need of neutralization. We valorize waste. What better than this? Diversification of sources, in other words. We have high selectivity, which means few-step process. If you compare that to 1,300 steps that they currently use in China for doing something similar, I would consider that a big leap in advancement. Low capital, which means that it's scalable, and environmentally responsible since we are not using any solvent organic liquids. And this is where you should be using your checkbooks wisely. We are in this phase of collecting enough money from SBIR grants, National Science Foundation, and Department of Energy to have progressed enough so that we can build our first pilot plant by 2020. So if you are interested in our project, we would be very happy to talk. I'm here, Thanasis Karamalidis, with my co-founder, Clint Noack. He's sitting over there, and we would be very happy to solve any of your questions. Thank you very much.